Hello everyone, welcome to our channel, the Digital Institute of Computing Technology. In this presentation, we will have discussion on the topic preprocessor directives. What are preprocessor directives? First of all, let's understand what is a preprocessor. Preprocessor is a part of the compilation process in C and C++ programming languages, which executes just before the actual compilation of the code. The preprocessor directives are commands in the source code that provides instruction to the preprocessor. They are used to make code more readable, manageable, and adaptable by handling tasks like including files, defining constants, and conditional compilation. Why are preprocessor directives needed? Let's see one by one. Code inclusion and modularity. Hash include allows inclusion of other files, enabling code reuse and modularity. Standard library headers and user-defined headers can be included, making it easy to organize code across multiple files. Example, hash include stdio.h. stdio.h is a standard library header. Hash include myheader.h. Myheader.h is a user-defined header enclosed in double quotes. Next, macro definitions. Hash define and hash undef are used for defining and undefining macros, which can simplify the code by creating constants or inline functions. Example, hash define pi with a value of 3.14, hash define square, which defines the square of a number. We can also undefine these macros using hash undef. Conditional compilation. Hash def, hash ndef, hash if, hash else, hash elsif, hash endif. These directives allow the compiler to compile or ignore parts of the code based on certain conditions. This is useful for platform-specific code, debugging, and including or excluding features. Example, hash def debug, printf debug mode, hash ndif. Here, the debug mode will be printed if the macro debug is defined, otherwise not. Error handling. Hash error generates a compilation error with a specific message. It is useful for catching unsupported conditions or configurations during preprocessing. Example, hash ndef supported version, hash error unsupported version, hash ndif. If supported version is not defined, the compiler will throw an error. Unsupported version. Pragmas and compiler instructions. Hash pragma provides special instructions to the compiler, which can include optimization, warnings, or other implementation specific features. Hash pragma once is a preprocessor directive in C and C++ that ensures a header file is included only once in a single compilation. It prevents multiple inclusions of the same file, which can lead to errors due to redefinition of classes, functions, or variables. What is the purpose? When you include the same header file in multiple files or through different paths in a project, it can cause problems such as symbol redefinitions. Hash pragma once helps avoid this by ensuring that the file is processed only once, regardless of how many times it's included. How it works? The compiler keeps track of files that have been processed. When a file with hash pragma once is encountered, the compiler ensures that it does not process the file more than once during the same compilation. Locate bug or code. This macros expands to the current source file name, line number, and function. Underscore underscore line underscore underscore macro expands to the current line number in the source code. Underscore underscore file underscore underscore macro expands to the name of the current source file. And underscore underscore function underscore underscore expands to the name of the current function where it is used. These macros can be useful for debugging, logging, and error handling, as it allows you to easily reference the source file name, line number, and function's name in the output messages. Token manipulation. Hash and double hash. They are used within the macros for stringifying and token concatenation respectively. This allows for more complex and dynamic macro definitions. The first macro, toString of x, converts the argument x into a string literal. The hash operator is known as a stringifying operator in C or C++. It is useful when you need to convert a macro or a value into a string during pre-processing, especially for things like logging, debugging, or embedding variable names in error messages. The second macro, concat of a comma b, concatenates two tokens a and b into a single token. The double hash operator is a token pasting or token concatenation operator in C or C++. This is typically used when you want to combine identifiers or symbols, like creating variable names dynamically by combining parts of the words. Now let's consider one example. This code demonstrates the use of macros in C to define a symbolic constant maxlen, find the maximum of two values, and absolute difference between them. Let's break it down. Hash define maxlen 100 defines a constant maxlen with a value of 100. Hash define max of a comma b macro computes the maximum of two values a and b. It uses a ternary operator. If a is greater than b, it returns a, otherwise it returns b. Hash define absdiff of a comma b macro computes the absolute difference between the two values a and b. If a is greater than b, it returns a minus b, otherwise it returns b minus a. This ensures a non-negative result. In macros max and absdiff, parentheses around the parameters and entire expression ensure correct order of evaluation when used with more complex expressions. Now let's consider the main function. Here, variables x and y have been initialized to values 10 and 20 respectively. When the macro max x, y is invoked, x is replaced by 10 and y is replaced by 20. Since 10 greater than 20 is false, the macro evaluates to 20, which is stored in the variable max. Using absdiff macro, since y is equal to 20 is greater than x is equal to 10, this evaluates to 20 minus 10, which is 10, and this value is stored in diff. Now let's see the macro expansion of some complex expression. In this case, we are using absdiff macro to find the absdiff of 10 and 2 plus 3. This will be expanded to 10 greater than 2 plus 3 in brackets. If 10 greater than 2 plus 3 is true, it expands to 10 minus 2 plus 3 in brackets. Otherwise, it expands to 2 plus 3 in brackets minus 10, which is also in brackets, which will be simplified to 10 greater than 5, then 10 minus 5, otherwise 5 minus 10. In this case, since 10 is greater than 5 is true, the output will be 10 minus 5, which gives the result 5. Now, in absence of parentheses, what will happen? Let us see. The macro would expand to 10 greater than 2 plus 3, which is not in brackets, and 10 greater than 2 plus 3, if it is true, will result in expression 10 minus 2 plus 3, and 2 plus 3 is not in brackets again. Otherwise, it results in 2 plus 3 minus 10, which according to operator present tense evaluates to 10 greater than 5, question mark, 10 minus 2 plus 3, otherwise 5 minus 10, which in turn results in 10 greater than 5, 8 plus 3, and minus 5. And finally, we will get the result 11, because 8 plus 3 is 11. 10 greater than 5 is true, resulting in the value of the expression 8 plus 3, which is 11. This is an incorrect output. The actual expected output was 5, but we got 11. So this is where the importance of parentheses comes to play. Parentheses ensure that the expressions are evaluated in the correct order. Without them, the operator precedence can lead to unexpected results. The output of this program is max 20, absdiff 10, absdiff with complex expression 5. So this covers an overview of preprocessor directives in C programming language. Hope you liked and enjoyed the presentation. Remain connected with us by subscribing to this channel for latest updates on this channel. Thank you.